Okay, so just a few more things with the ggplot. Just wanted to show you a couple more kind of graphs, just a couple kind of things you can do in ggplots that I don't know, maybe you'll want to use for your final project, maybe not, who knows. But I thought I'd cover some of this stuff, and yeah, let's take a look. Okay, so one thing that we have as a statistical tool is called a density plot. And this is what a density plot looks like. Density plot is kind of like a histogram, and perhaps it's kind of like a histogram, except you you draw like a smoothed out line over over the bins, okay, or the bars. So here's a density. This would be the kind of corresponding histogram. So it's so we've learned how to make a histogram, right? You do geom histogram, and it tells you, okay, you've got this many. This is using the diamonds data set, and we're looking at the distribution of carats, which is the size of the diamond, and we see, oh yeah, there's a lot of diamonds, about this size, and a lot of diamonds, right at this size. And basically, if we said, draw a kind of a smoothed out curve, we can do it with the density. And this reveals, some interesting kind of shapes. And we see, there's a spike right at one carat, kind of indicating that there, for whatever reason, there's kind of this mindset of like, when I get a diamond, I want it to be, at least 1 carat or something, right? Nobody wants to buy like a diamond that's 0.9 carats or 0.8 carats. If they're going to get a diamond, it's going to be 1 carat, and maybe half a carat, and maybe this looks like 0.7, just under 3/4 of a carat or something like that. So there's kind of these interesting spikes, a spike right at 1.5, spike right at 2. And so the density kind of is a smoothed out plot there. And just kind of like anything else that we have in ggplot, you can go to the reference, and as far as the different kind of geoms that we have, you can look at some of the arguments here, right? So we have geom density, and it shows you a bunch of kind of examples that you could draw here, okay? And there you go, okay? So this one is, this is what we have, geom density on carat. If you swap it and you say y equals carat, you'll get kind of the horizontal one. I don't think I've ever seen in like, quote, in the wild, like outside of this help page, I don't think I've ever seen a density plotted sideways like this. So this is very non-traditional, and I think people would be confused if they saw something like that. You can also change the width of your bins, or the width of the, I guess, what we call the bandwidth of the thing by, when you call density, you can say, you know what, here, when it's drawing out the smoothed out curves, you can see it kind of, when there's overlap, it doesn't try to like get into the, say, like the nooks and crannies of the distribution. And if you want something that that does kind of get into, say, the nooks and crannies, you can change this this value to something lower. So here's adjust, right? You can change the adjustment here, and you can see this distribution. This allows for kind of all the little the details, every little spike kind of gets its own kind of, peak in here, okay? Versus you can change it, kind of go in the opposite direction. So this is the default, and if you change it to something bigger, okay? Now it's like, painting with like a wider paintbrush or something that the lines get even more kind of smoothed out here. So those are some of the options. Okay, here it is even here. You can change the, you can plot multiple of these things by adjusting, setting the color, mapping the color to a categorical variable here. Okay, so here we have, I'm sorry, this is the, this is just more on histograms. Okay. So going back, with the density plot. Let me leave it at the default, but I'm going to map the color to say the cut of the diamonds. Okay, and we can see there's different it's a little bit hard to see, but you can see with a lot of ideal cut diamonds, there's a lot of diamonds that have lower carats, and as far as fair cut and good cut, you actually have a very large peak at 1 carat. And probably what's going on with this is that the diamonds, they come out these these funny shaped rocks, and then they cut up the diamonds so that they cut the raw diamond into basically the classical shape of a diamond, and sometimes in order to kind of get the diamond, the total mass of the diamond to be 1 carat, they'll the ideal shape has a certain angle, but they might cut it like at a funny angle in order to kind of retain the mass of the diamond. And so, if the priority is we want a 1 carat diamond, no matter what the shape is, you'll get kind of this poor cut diamond or fair cut diamond to maintain that it's 1 carat there. But anyway, so that's a density curve. Histograms, we're familiar with histograms, but there's more options that you can kind of set and adjust and change with the histogram. And so just for kind of the aesthetic purposes, you can change the fill color, right? So here I'm doing fill equals light blue. It gives you kind of this little message that says it's using bins equal to 30, and that you're allowed to change the number of bins to something else if you want. You can kind of just ignore this message if you want, or you could go and choose bin width and set it to be something else. But here, just for your own kind of settings, you can change the color of the fill color. And I kind of enjoy having solid lines around the bars, and so that is set using color. Okay, so here I have the fill color to be light blue, and the color of the histogram itself, the lines outlining the bars, in black, and this is a kind of a nice appearance there. And what you can do is you can also combine a lot of these kind of curves together, or different plots. So here we're saying make the histogram, and on top of that, plus geom_density, and we're going to add a density to this. So, depending on the plot that you're making, a lot of these kind of geometric objects in ggplot, you can kind of just stack on top of each other and add on top of each other, and you're just kind of adding an additional geometric object here. So here we're saying add the density curve right on top set it, make it a red density, and you get something that looks like this. This is a little bit harder to read, but you can also set the kind of the fill color on the histogram based on some categorical variable here. So here I still have a histogram where we're looking at the carrots, but what we're going to do is we're going to color the bars based on the cuts. Okay, and so here you do see a little bit of the kind of what we saw back here, in that the yellow, the ideal cut, has kind of the largest peak. For the smaller diamonds, it's easier to get those to be ideal cut, and then kind of in order to kind of make sure we get diamonds that are 1 carat, we're willing to take on a few more fair, good cut diamonds. So it's kind of an interesting side effect of having these numbers, and just kind of the shopping preference of people is that there's something about having a diamond that's exactly 1.0 carat to kind of I guess provides a demand for these lower grade cut diamonds, but of the appropriate size. Oh, here's this is what we did already with the densities and the different colors mapped to different sized cuts. Here to kind of make it a little bit the lines thicker, I changed the line width equal to 1, and that makes your lines thicker. Okay, you can also put in, you can have the densities colored in. So here I have the fill color also associated with the cut. Okay, now if I just did let me so if I did fill equals cut, okay, then this is what it would end up looking like. And every kind of color is opaque, and so you can't actually see what's going on. So so one thing I had to do in order to kind of make the visual work is, under density, I just set alpha equals to say 0.1, right? And so that reduces the transparency of each of these things. And so now you still get a little bit of shading, and I don't know, maybe 20% is better. I don't know. I don't know if coloring is all that necessary, but if you wanted a little bit of tint or something to your plot, you can do that. You can add the fill color there. Okay. Before I forget, let me give you your first view quiz answer for today. Today's first view quiz answer is the letter A. A as in apple. A as in apple. Okay. That's what we have. What do we have over here? We have, they mapped depth, the depth table. Okay, that's interesting. It's quite a different shape. Depth is like how thick the diamonds are. Okay, and so I think a certain percentage, and so again, you look up like diamond depth, ideal diamond depth and table cut, right? So again, any data set, whatever it is, it's good to look up some information. And so you get, this is what a diamond looks like, right? And then so this part is called the table, and then this is the depth. and then you can ask, what is, what's the ideal depth? And so, for round diamonds, the ideal depth is between 59 and 62.6%. And so, we can see what happens if we put depth on here. Okay. And indeed, it looks like for the ideal diamonds, the depth is right around 61, 62. So it says 59 and 62.6. And it does seem that that does seem like there's a spike here for right around 62. Something around there, 61, 62. We don't really see that many 59, depth 59, but a lot of depth 62, which kind of aligns with this whatever diamond website tells us. Okay, like I don't know anything about diamonds, but sure, diamonds.pro, it sounds like they have something to say about diamonds. So anyway, this is what it is, the ideal depth percentage, and we could see that as the depth changes. Okay, so if we end up getting like 63%, 64%, 65% depth, that reduces kind of the quality or the rating of the cut of the diamond. So that's kind of interesting. And so I'm not sure what's going on out here. Like, why do we have values all the way at like depth 80 or depth 50? I'm not quite sure, but let's just kind of zoom in and let's look at 55 through say 70 for the depth. So we can kind of zoom into the this portion, and it gives us a warning that we removed some of our data. It says warning 45 rows removed, okay, because they are outside of our X limits. But yeah, we can see, sure enough, ideal cut, they're all right around 62%. Okay, so here's 60, here's 65, this would be 62.5. So right around 62%, that seems to be kind of the spike for ideal cut diamonds. And it looks like if you're at 63%, and then you drop down to very good, and at 60, 63.5, 64%, 60, closer to 65%, now you're fair. Anything higher than that, it's a fair cut diamond. So you get kind of these narrow ranges for what the depth is. Okay, and again, the idea is because you've got these raw diamonds and you have to cut them in order to kind of preserve. It might be more suitable to have like a diamond with more depth that's less ideal. Okay, more depth in order to kind of just get a little extra mass into your diamond, so you can say, oh yeah, this diamond is 1 carat, because you can imagine if you make the diamond deeper, that's going to make the diamond bigger, but at the cost of making the cut less great. Okay, so it's not that anybody should be doing the diamonds data set, but there's interesting stuff to kind of be revealed and gleaned from the data. All right, here is an example where you can take a data set and you can do some stuff. So here I just filtered and I said, let's look at just the difference between the fair cut diamonds and the ideal cut diamonds, right? So these are kind of the two extremes between, like the good ones and the bad ones, or the, the lowest rating is kind of ideal versus fair. And so, what I'm doing here is basically, you can take your diamonds data set and feed it into here, but you can also do stuff to it, right? So you can take filter and take the variable cut, and you can filter it. And so here I'm going to say I want cuts to be either an ideal or fair. Why am I getting maybe it should be. I'm getting all kinds of diamonds, filter, cut. I don't know why I have all these unmatched opening brick. Oh, okay, that didn't, could not find diamonds. Could not find function diamonds. What am I? Okay, there we go. All right, so here is the diamonds data if we're looking at the depth, and we can see, yeah, there's quite a stark contrast between fair and ideal cut diamonds when we're looking at depth, but also just in terms of like, say, carat. Oh, we don't want the X limits here. Okay, for carat, yeah, we see, there's quite a bit of difference. And even you can, okay, let's take a look at the table, and there's kind of something interesting is happening with the table of the diamonds, and I'm not quite sure. Really just find percentages going on there. Something. Okay. Table. Interesting. Something quite different. But yeah. Okay. So we can see, different distribution in terms of the size of the diamonds right there. All right. That's just a kind of a bunch of density plot things. Let's see. There were a couple more. Yeah, that's what I wanted to show you there. Okay. All right. There's the other thing is some of your data sets have like longitude and latitude coordinates, and you might want to say plot some of those values onto a map. Others of you might have data where you gathered data from, say, each state or something, and you might want to kind of create a map using that. And so I wanted to show you just a few examples of drawing maps with with R, and so you can kind of create maps. And so one of the there's a library that you'll want to load up, and it's called Library Maps. Okay, and this data set that we're going to take a look at is, it's not a great, it's a little bit of it's on crime data, and it has all kinds of stuff, and it's like, oh, how many like murders are there and something like that. So it's not great, not a great subject, but it allows us, we can kind of do some plotting here regarding some plots and maps here. Okay, I'm sorry. Let me just take this this call for a moment. 1 second. Okay. Thank you for sorry about that. All right. So so for this, I'm going to call in a library called Library Maps, and this library includes basically like all of the shape files. So it tells you like, okay, if you want to draw California, like draw this coordinate and this coordinate, and it will kind of allow you, it will tell R, what part of the map to kind of do this stuff here. Okay. So here we'll take this data frame called US arrests, and we're going to take the and create kind of this crimes data frame here. Okay, so we can kind of take a look at this, and it has crime statistics. Okay, which is again not the greatest, but you can. So it says, from 1973, okay, kind of the number of violent crimes in that occurred in 1973. Okay, so and what we'll do is we will load up the state level map data. Okay, so you can ask for help on maps. Oops. Double question maps. Draw a thing, but we'll look at some of the map data, and we'll look at state level map data. Okay, so we're going to create this thing called states maps, and here, if you try to look at the data set, it's very complicated. Okay, because it says if you want to draw, say, Alabama, the borders of Alabama consist of all of these kind of like coordinates, and it's basically a whole bunch of like points, and then you'll like draw a line to connect all of the dots. Okay, and so you can see, just to draw Alabama, there's like 202 tiny little line segments, right? And then to draw Arizona, these are all of the kind of the line segments needed to, or the little points to draw. But anyway, that's how the data gets loaded. And so now what we can do is we can create a map here. Okay, so we're going to so again, if we look at, say, the crimes data, right, there is the state. Okay, and we'll look at the murder rate in 1973 for each of these states. Okay, so we're going to do we'll do ggplot. We'll look at crimes, and then we're going to map. All right, so in this case, the map ID, which comes from over here, when we're looking at kind of the region, and it says Alabama. So one thing about this is the state names are all lowercase, and so you have to kind of get those to match. And so so that's one of the things that we've done here is for state, we've had to kind of make all of these things lowercase in order for it to get to map here. Okay, and to match up. And so we're going to do map ID equals to state, and then we will take the murder rate and associate that with the fill color. Okay, and so we're going to do geom underscore map, and again with the ggplot. Polygons from a reference map, so you can look up geom underscore map, and they've got well, you can have your own kind of polygons, but different plots here. Okay, and so we will we'll do this, and we're going to use the states map. Okay, that's how we have to provide it a map, and this will be our border color. Okay, and here we're going to make sure that we can fit the entire kind of map here, and I'm going to go ahead and plot this thing. And so this is what our map looks like. This is where we have the latitude and longitude coordinates on the same kind of axis, which makes the United States look a little bit kind of flatter and wider. So you can try changing the so that makes it go the wrong way. You can try kind of changing the coordinates to something a little bit. Is this doing anything? Or is it, do I need, okay, so now we've made it a little bit too tall. So probably the sweet spot as far as like what we're accustomed to seeing, how the United States is drawn is probably something around here, where you're going to specify 1.3. That's the ratio between the X and the Y. And so this is kind of colored based on whatever values or data you have. And so you could take some other say election data or something and look at what proportion of people voted for a certain candidate, and you could say high numbers will be blue and low numbers will be red or something, and you can kind of plot that, and you'll get like red, and different areas will be red and different areas will be blue, and things will be purple in between and stuff like that. And that's just one way to kind of plot values onto say a map here. Okay, so we have map information. I've given you one view quiz answer already. I guess I'll go ahead and give you I'll give you the second and third view quiz answers, which will be the letters B and C. So B is your second view quiz answer, and C is your third view quiz answer. B and C, second and third view quiz answer. Okay, the map library also has a world map included, and so here I've got, I'm going to make a simple data frame where I've got USA, Canada, China, and I put like a, like you might have a categorical variable. And so I don't know, let's just add a few more. All right, so we'll put Japan, let's say is Asia, okay? And so anyway, and I guess you could go through every, list off every single country there. And so here, rather than mapping, numeric variable, we'll do like a categorical one, okay? And so when you do something like this, it's only going to create plots, okay, for the kind of the countries or values that you have. So if you don't have a value, you actually have to kind of get all of the countries in there, and you might not, otherwise your map's going to end up kind of being blank here. Okay, so here I only have, say, USA, Canada, China, and Japan, and so only those maps, only those countries appear, right? Which makes the world look like we're missing a whole bunch of stuff. Okay, and so so here I'm going to take the world map, right? And so if you look at world map, it has a whole bunch of places. Okay, so you can see kind of all sorts of stuff here. So what I'm going to do is I'm going to just kind of gather, get all of the country names. Okay, and so country names, we've got 252 values here. And I'm trying to, this might, I don't know how updated or outdated this map is. Yes, Sudan and South Sudan, but we still have Lesotho, which has been renamed to Eswatini, I think. No, Lesotho is still that. Sorry, what is it? Eswatini, is that listed here? I don't see it. Swaziland. Let me see. Okay, it's still called Swaziland in in the list of countries, although they've kind of they renamed themselves in 2018 to Eswatini. So or Eswatini. No, Eswatini. Yeah, Eswatini. Yeah, they renamed themselves, so it still has kind of the old country name here. But anyway, this is our list of unique countries, and so here I'm going to create a data frame where I have basically just nothing. I just have all the countries. And right now, the continent column is just empty, okay? Because the other, this one that we created, we only had 4 countries listed, and they're, kind of associated continents listed here. And so here we're going to have kind of a blank data frame, and we'll just start filling in some of the countries that we say want to color in, okay? So let's say we want to color in USA, Canada, Mexico, and we're going to put North America into those. And so one way I can do this is I can just say, with our data frame, take the continent variable, and then if the country is one of these things, then what we're doing is we're going to set those values to say North America here. And so, so what that does is if I scroll through my data frame, we can see we have set the value for Canada to North America, the value for Mexico to North America, and the value for USA to North America. All right, and you can go through and you can add more things. And right now I just have North America, but we might want to have some other kind of thing, right? You could, if it's like a political thing, you could say, member of G20 or, member of G7 or, whatever it is. Okay. Here we'll take some values and say these are, we'll label this East Asia. Okay. And so now our data has additional things, and we have, China, as far as kind of the region, we will say East Asia or things like that. And so now if I want to kind of fill this in, I'm going to use kind of the same command that I had before. And we're going to associate the fill with, whatever values on the continent. A bunch of other things now have just NAs that we never put anything in. And so here we now have a map where we've colored in whatever it is that we want here, okay? And we can make this a little bit wider, okay? And, it's too much. Let's see. I don't know. It's too tall. I don't know. So, Mercator projection, not the greatest, right? But I don't know. Is there a way to change the map projection? I'm not sure. Map projections. Projection CRS 5070 coordinate system. Oh, geez. Okay, so yeah, if you want to adjust your coordinate system, you can do this. The Conus-Albers projection. So if you're like into maps, you have all kinds of like map projections, right? And a list of map projections, right? So kind of this is often we put X and Y coordinates on the thing, and this just kind of blows up things at the poles. So Antarctica is ridiculously huge, and so is Greenland, and then it shrinks things around the equator. So Africa looks tiny, and so it's not great. And so we have different kind of coordinate systems, and something for, say, like the United States, you can actually put in a different coordinate system. And I guess coordinate system 5070 will do it. Coord SF. Oh, I need something. I need to load something here. Require maps. Okay, I got to figure this out. Coordinate SF. Function, there's no package. Coordinate SF. Okay, so I'm not quite sure what I did wrong here. All right, well, I'll have to look that up regarding changing your map projection. But there is a way to do it. I just don't remember how to do it right now. But there is. Let me see. ggplot map projection. Map projections, coordinate map. Okay, projection Mercator. What else can I do? Coordinate map Gilbert projection, coordinate map orthographic, coordinate map conic. Okay, so let me try this. So these are not for the world. For the United States, that might work. Map projection, package map projection is required. Okay, let's go ahead and install that. Oh, and I'm running out of time here. Okay, so all right, so here's the US on a different map projection where we've, you can see kind of the conic shape here. Okay, sorry, I've gone over my time here, but so we'll call it a day. But yeah, you can adjust the map projections for different things, and yeah, I guess you can kind of see what it looks like. Okay, map projection. All right, so here we have more information if you want to look at it. Okay, but anyway, that's that. In case you wanted to include some maps in your final project, if that applies to your data, which it may or may not, and so that's some information. And again, I'm having office hours throughout the week, so stop on by. I'm happy to lend kind of my help and knowledge to help your groups get going there. Okay, thanks for showing up today, and have a great rest of your day. We will see you. Well, you know what? Actually, Friday might have to be online or asynchronous or something, just because there's I don't know, there's stuff going on over here. So so I'll let you know. I appreciate your flexibility. I'm sorry. Okay. Thank you, everyone. All right. We'll see you later.